Okay, so we're looking for a third degree polynomial with zeros being 1, 2, -3. And when we plug in -2, we want the answer to come out to be 2. So we've got a couple conditions. First thing is I know my zeros. So I'm going to start there. I know if I plug in 1, I get a 0. If I plug in 2, I get a 0. And I plug in -3, I get a 0. I'm going to go ahead and multiply these out. So multiplying these, however you're going to distribute that, gives you x squared minus 3x plus 2, still times the quantity x plus 3. And we're going to go ahead and multiply this out one more time. So it's going to give me x cubed minus 7x plus 6. So it's just done through distributing. I actually did it using a little method here, make things a little bit quicker. So I use this just so if you don't know this technique, you can use this. And I multiplied this way. So here I got x cubed, here I got 3x squared, here I got -3x squared, here I got 2x, here I got -9x, and here I got 6. And so if I start putting these together, those became 0. That gave me the -7. There's my 6. There's my x cubed. All right. So we now have the function that has these zeros. Problem is, it hasn't met this criteria yet. So let's go ahead and take a look and see how do we get that next piece. So what I have right now is p of x is equal to x cubed minus 7x plus 6. And I know that p of -2 has to become 2 as a final solution. So I'm going to plug in -2 and see what I get. So -2 cubed would be -8. -7 times -2 would be positive 14 plus 6. So over here I've got 20 minus 8, which would be 12. So what I want to know is that's not the right answer. I need it to be 2. So what do I have to do so that I can get that to be the correct answer? Well, what I had to do was multiply this by 1/6. Okay, 1/6 of that would give me the 2. So that means really when I go to write on my final solution here, what I have is 1/6 of x cubed minus 7x plus 6. And if you need to multiply all that out, you can, but if not, there's our final function.